morning, my dear students of class 11 science. Today we will be discussing about a very important topic, that is hybridization. So this topic is very important, therefore you have to listen to it very properly. Okay? So hybridization is a phenomenon where these atomic orbitals are intermixed, which are those atomic orbitals which are having nearly the same energy. Now they are intermixed. And after mixing they give rise to orbitals which will be equivalent orbitals. That means you will not be able to distinguish one orbital from the other. You will be getting equivalent orbitals, and these orbitals will be having same energy, similar orientation and identical shape. So to understand this better, let's take an example. Okay, with example, I'll give you some example. With that, you'll be understanding it better. So here, atomic orbitals are intermixed. So let's discuss about S and P orbitals first. So whenever S and P orbitals they are intermixed, they give rise to three different types of hybridization. That is Sp3 hybridization. Number 2, Sp2 hybridization, and number 3, it is Sp hybridization. So in case of Sp3 hybridization, let's take example. This is the example of methane. Okay? Now whenever you do the hybridization, you have to take the central element. Here in methane, carbon is the central element. You know its atomic number, it is 6. So write its electronic configuration: 1s2, 2s2, 2p, 2. Now these orbitals are arranged according to increasing energy level that we have discussed from Babu principle. So whenever I have to draw this, then this 1s orbital will be lying in the lowest, and it will be having 2 electrons, and just above it will be 2s, this 1s orbital, lowest in energy. Yes or no? Then 2s, then comes 2p. So here you have these 3 orbitals arranged in increasing order of energy. Now this is before intermixing. Now what will happen? Now whenever this is the ground state, okay, this is the ground state of carbon. Now whenever it gets excited, as we have discussed in our previous video, then what will happen? Since it has vacant this space, one of the electrons from 2s, this is 2s and this is 2p. One of the electrons from 2s will be promoted to 2p. As a result, what will happen? You will be getting again 2 electrons in 1s. Then you have 2 electrons. Now here one electron has been promoted to the p orbital. So this is your 1s, this is 2s, this is 2p. Yes or no? Here this is electron promotion. Means whenever it has higher energy, it gains energy, then one of the paired of electron will be shifted to the vacant space. Now after this, whenever Sp3 hybridization is involved, as I told you from the definition, hybridization is intermixing of atomic orbital to give hybrid orbitals. Now these hybrid orbitals will be identical in all respects. In their energy level, they will be having similar orientation, their shape will also be identical. Now once that is done, then what will happen? This 1, 2, 3, 4, these 4 orbitals containing unpaired electrons, now they will be hybridized. This 1s is left as it is. Okay? Then these 4 orbitals will be hybridized to give you 4 identical orbitals. See, I am writing them separately. Okay? Now these are what? these are having similar energy, their shape is also similar, and these are what? These are hybridized orbitals, and this is known as what? Sp3 hybridized orbitals. Hybrid orbitals. Can you see that? They were having differences in energy, and their shapes, this was P, you could distinguish it as what? P, this as S was spherical, P was double, it was double shaped, but after hybridization, everything becomes same. Now this hybrid orbitals will be involved in what? Bond formation. Okay? So now, in case of methane, this unpaired electrons now will be bonded with one electron of hydrogen to give you what? To give you Sp3 hybridized structure, that is tetrahedral structure of methane. Now, if you let's draw the molecular orbital structures. Now, in case of methane, carbon is present at the center, and here what you have is, now these four orbitals, these four Sp3 hybrid orbitals will be involved in what? Will be involved in bond formation with hydrogen. Okay? Now, here this is Sp3 hybridized, this is also Sp3, this is also Sp3. Now these hybrid orbitals, as you saw, it is bonded with hydrogen for hydrogen, and hydrogen has one s orbital. One s orbital is spherical in shape. Now it is bonded with what? Four hydrogens. Okay, and these are what? One s orbital of hydrogen. One s orbital of hydrogen. Now this will give rise to tetrahedral structure. That means you can have a look at it. Whenever you are drawing the bond, then hydrogen is present. Here hydrogen is present. Here hydrogen and here hydrogen. These two are equivalent. Okay, these two are equivalent, and the bond angle here is 109.5 degree, or you can write 109 degree 28 minutes. So the bond angle between this hydrogen and hydrogen in methane is how much? 109.5 degree. So this is how you have the orbital diagram for methane. Understanding of this hybridization is very important. Hope this is clear now. Now here, these four unpaired electrons. Four unpaired electrons. These unpaired electrons are what? Hybridized, and they form what? They are involved in bond formation with 1s orbital of what? Hydrogen. How many of them are there? Four of them are there, and this is the structure of methane. It has tetrahedral structure, and the bond angle is 109.5 degree. So let's discuss about now Sp2 hybridization. In Sp2 hybridization, you can take example of ethene. That is, you have two carbons and four hydrogen. This is the example of Sp2 hybridization. Now here again, carbon is involved. As carbon is involved, you have this energy level diagram. Two electrons, one s orbital. You have again 2s orbital. Then you have 2p orbital, where two unpaired electrons are present. So once electron is excited, energy is given, what will happen? As in the previous case, 2s electron will be promoted to this 2s electron is promoted to 2p electron. This is 2s and this is 1s. Now, in case of Sp2 hybridization, what will happen is this 1s electron will remain as it is, and here you have this structure where in case of sp2 hybridization 3 atomic orbitals will be hybridized to have the similar energy level. This 3. Now these 3 will be occupying one electron each, and one of the orbital is unhybridized. One of the orbital is unhybridized, and this is the 2p electron. This is unhybridized. Unhybridized orbital, and this 3 are what? They are sp2 hybrid orbitals. Now, whenever you can see that these 3 are having identical energy, and this is the unhybridized electron. Why? Because it is having higher energy than this hybrid orbitals, therefore this is unhybridized. Now, these sp2 hybrid orbitals will be involved in what? Now, in case of C2H4, let's discuss its structure. Now, in ethene, you have 2 carbon. This carbon and this carbon will be forming sigma bond, overlapping, overlapping, and each carbon is bonded with what? Each carbon is bonded with 2. These are sp2 hybrid orbitals. This is sp2. This is also sp2. This is also sp2. Now it is bonded with 1s orbital of hydrogen, and these are all what? Sigma bond. These are what? Sigma bond. Similarly, this carbon is also having sigma bond with 1s orbital of hydrogen. This is sp2 hybridized. This is also sp2 hybridized. Now this is hydrogen, and this is 1s, and these are all forming what? Sigma bond. They are forming sigma bond. Can you see that? See, these 3 hybrid orbitals, sp2 hybrid orbitals, are involved in formation of sigma bond on each carbon. So this carbon is having sp2, sp2, sp2. Now these are involved in sigma bond formation with hydrogen atom. Now, you know, in case of sp2 hybridization, here you have unhybrid orbitals. Now these unhybrid orbitals will contain this electron, okay? This carbon as well as this carbon. See, these are unhybrid orbitals, these 2. So I'm setting it down so that you could differentiate it. Now these 2 are unhybrid orbitals. Now these 2 will overlap laterally. They are overlapping what? Laterally to form what? Pi bond. So we have discussed, whenever there is lateral overlapping, that will result in what? Pi bond formation. So these 2 unhybrid orbitals will be overlapping to give you what? Pi bond. So you have 1 pi bond. Please don't count it as 1 and 1, 2. No, it's only 1. This is having 2 lobes. Yes or no? P orbital has 2 lobes. This as a whole itself is 1 orbital. This as a whole itself is 1 orbital. Therefore, there is overlap on the upper side and overlap on the below side. And this will result in 1 pi bond formation. Okay? So this is the structure of what? This is the hybrid orbital structure of ethene. Similarly, in your syllabus, you have for this sp hybridization, that is C2H2 as well, where 2 pi bonds will be formed. That will be your assignment. Please do it as your home assignment and send me in my WhatsApp number. So this is the structure of methane, ethene, and 1 will be your homework. In the next class, we will be discussing the application of hybridization, which is very important. Till then, take care. Thank you.